Okay, so up to this point, we have covered the climate zones. Then we have seen ASHRAE standard 55, which gives define the thermal comfort as the conditions of mind that expresses satisfaction with thermal environment. Then we have seen the factors affecting the thermal comfort. So this is the first one is the metabolic rate that we have seen 1 MET stand for 60 watt per meter cube. Then we have seen reading will consume less MET. The typing will increase the MET rate. Walking will again increase the MET rate. And finally, the running will consume most energy. That means metabolic rate is very high. So these are some typical metabolic rates that we have seen. Then just now we were talking about the air quality index. Okay. So if it goes above 200, it is very unhealthy, right? Okay. So CLO stands for, or it is a unit for clothing insulation. The unit used to represent the thermal insulation from clothing, where 1 CLO is winter clothing and 0.5 CLO is summer clothing. So in summer, as you know, we wear minimum clothes, or the quality of the cloth is very thin. In summer, we try to wear cotton shirts, cotton pants. In winter, we try to wear t-shirts or jackets with jeans. So between them, this flow value will vary. Now next, it is about the thermal exchange of body with environment. Okay. So when you are sitting, doing work, running, whatever you are doing, so constantly you are radiating, or you are giving up some heat from your body, and also you are accepting the heat also. That means not only you are giving the heat, you are accepting the heat also. So constantly there is a thermal exchange of your body with the environment. So see there is this picture is there. This is a person which will receive the heat from sun through radiation. Okay, through air he will receive the heat by convection, and through ground it will receive the heat by conduction, because there is a contact here. Solid contact here is there. It will receive the heat by conduction. Now through his skin, some amount of perspiration will take place, right? Then there will be sweat exhalation. So this will contribute to latent heat. Whenever you are sweating, you are giving up heat in the form of water vapors. So that will be latent heat. Whenever there is an increase in temperature, that will be sensible heating. Okay. So both way we receive heat, sensible heating or latent heating. We receive the heat, right? So we'll see that one by one. So this is the equation, grand equation here. Qm minus W is equal to QV plus or minus QR plus or minus QC plus or minus QS plus or minus QCO. Okay, so we'll see one by one. What is it? QM is metabolic heat rate. So that is a heat produced, heat gain. W is useful rate of working. So we are doing work, that means we are expensive some amount of energy, so that will be negative. So this is heat produced, that will be positive. This is a negative. So as you can see here, QM minus W. It is a LHS. Now RHS, we have heat loss by evaporation. QR is heat loss or gain by radiation. QC is a heat loss or gain by the convection. And QS is heat stored in the body. One more is remaining, that is QCO, that stands for heat loss by the conduction. Heat loss or gain by the conduction. Here QC refers only for convection. I have added one more, that is QCO. So QM minus W is heat to be dissipated to the atmosphere. So this much amount of heat we have in our body. Now it will be balanced with all the losses from the body. Okay, so this is the heat generated QM, and heat lost is this much plus W. Thermal condition, if QS is positive, QS is heat stored in the body. Temperature of body rises, that means we may experience fever. If QS is negative, temperature of body falls down, that means it is a case of cold. If QS is equal to 0, that is a comfortable conditions. I hope you are understanding. When the heat in the body will increase, we may experience fever or body heat. If the temperature of the body falls down, that is QS is negative, it is a case of cold. If QS is 0 or nearly 0, it is a case of thermal comfort. So psychometric properties of air, this will be very helpful in determining the thermal conditions. Already we have seen in chapter number 4, dry bulb temperature, wet bulb temperature, relative humidity, humidity ratio, dew point temperature, vapor pressure, degree of saturation, right? So this was the psychrometric chart we all have studied. So in that case, on abscissa we have DBT, on ordinate we have specific humidity. Then here we have enthalpy scales. Then we have 100% saturation curve. This is RH. On RH curve, 100% RH curve or saturation curve, we have WBT values. WBT values 5, 10, 15. These are the WBT values. Again, we have some inclined lines, vertical inclined lines that will be specific volume lines, right? Again, somewhere here you will see ESHF scale will be there. Again, enthalpy lines, constant enthalpy lines also will be there. Okay, this we have studied. Now, next is very important term is mean radiant temperature. Mean radiant temperature. Mean radiant temperature, right? So the radiant temperature is related to the amount of radiant heat transferred from the surface and depends on the material's ability to absorb or the emit heat or its emittivity, right? So there are two images are shown in the PPT. Now, first one is actual room. In actual room, what will happen? The inside temperature, okay? So there is the heat transfer by radiation through glasses, right? Directly the sun rays will fall onto this person. In that case, what will happen? Whatever temperature inside the room, that is T2, will be lesser than T1. That means if you are sitting directly next to the sunlight, you will experience a temperature. That temperature will be always greater than T2. Okay. But if you imagine a room, okay, if you imagine a room where whatever temperature you are feeling, T1 temperature is constant everywhere. Okay, that means whatever radiant heat you are receiving, that has been distributed in the room evenly. Okay. So the mean radiant temperature depends on the temperature and emissivity of the surrounding surfaces as well as view factor or the amount of surface that can be seen by the object. So this is a radiation theory. It is not in your syllabus of HMT. But for GATE, those who are preparing GATE, for them it is very important. View factor, okay? So view factor that you have to first calculate, then you can calculate the radiative heat transfer, right? So the mean radiant temperature experienced by the person in the room with the sunlight streaming in varies based on how much of his or her body is in the sun. जेवढं तुमचं एक्सपोजर असेल जास्त सोलर रेडिएशनला तेवढं तुम्हाला जास्त टेम्परेचर जाणवेल, राईट? Okay. So there is actually another standard definition for MRT. It says that, so with the help of this diagram, it is said that suppose previously the temperature of room was T2, you are receiving some radiations of sun, will experience some higher temperature due to radiation, that is T1. So T1 is greater than T2. So suppose and there is an imaginary room where all the radiations are evenly distributed, right? So that temperature in that imaginary room, it is termed as mean radiant temperature. If you go by the definition, you won't understand the concept. Concept is तुम्ही रूम मध्ये बसलाय, तुम्ही बाहेर गेलाय, what temperature मध्ये डिफरन्स जाणवतो. आता तुम्ही जर समजा एक थर्मोमीटर आणला आणि रूम मधल्या बाहेरचं टेम्परेचर मेजर केलं, त्या केस मध्ये सेमच असणार आहे. But why we feel hot outside and why we feel less hot or cool inside is because of this radiation. बाहेर गेल्यानंतर अंगावर आपल्या radiation पडतात. Radiation मुळे आपल्याला असं वाटतं की टेम्परेचर जास्त आहे, पण टेम्परेचर तर सेमच असतं आत आणि बाहेर. So when you take into consideration this radiation and calculate the temperature, so that will be mean radiant temperature. Okay. Next is effective temperature. The degree of warmth or coldness felt by the body depends on dry bulb temperature, relative humidity, and air velocity. The effective temperature is an index that correlates the combined effect of DBT, RH, and air velocity on human body. That means it will take into consideration all these three factors and it will give you some effective value. That means this is the effective value for this condition. तर मी तुम्हाला एक्झाम्पल सांगतो की जसं सपोज टेम्परेचर आहे 40 डिग्री सेल्सिअस समरमध्ये आणि ह्युमिडिटी जास्त आहे, लेट अस से ह्युमिडिटी 60% आणि एअर वेलॉसिटी पण जास्त आहे. त्या केसमध्ये तुम्हाला एवढं हॉट जाणवत नाही, ठीक आहे. पण त्याच केसमध्ये टेम्परेचर 40 जसं आहे तसं आहे, बट रिलेटिव्ह ह्युमिडिटी डिक्रीजेस, समजा 30च झाली, एअर वेलॉसिटी देखील कमी झाली तर तुम्हाला जास्त उकडायला लागतं, राईट. तुम्ही उन्हाळ्यात बाहेरून आत येतात त्यावेळेस फॅन चालू करता, राईट. तर काय होतं या केसमध्ये, बाहेर एअर वेलॉसिटी फार कमी असते, आत आल्यानंतर तुम्ही एअर वेलॉसिटी वाढवता, तुम्हाला असं वाटतं की थंड झालंय, तर ते थंड होत नसतं. टेम्परेचर काय सेमच आहे, बाहेर काय आणि आत काय. You are increasing the air velocity with the help of fan. Okay, so that effective value of temperature is calculated here. It is called as effective temperature. So in that case, they're considering dBT, they're considering RH, they're considering air velocity, and they're calculating one effective value of the temperature. The practical application of concept of effective temperature is represented by comfort chart. Okay, so that we'll see. Next is operative temperature. So again, if you want to write down, you can write down because there will be MCQs on this chapter in ISC as well as in university exam. So operative temperature, TOP is the factor. This is a factor. This factor is a weighted average of air dBT and mean radiant temperature into a single factor. So if you have calculated the mean radiant temperature and if you know the dBT, so by knowing the both, they are calculating the operative temperature. Mostly when you are doing the cooling load calculation, in that case you are referring to operative temperatures. Okay, now this is the main thing of this chapter, which is called as comfort chart, which is called as comfort chart. Okay, so we'll understand very slowly. Okay, so as all of you can see it, the abscissa contains dBT now, but in this case the ordinate is WBT. Previously in psychometric chart the ordinate was specific humidity, now the ordinate is weight bulb temperature. So for this scale and this scale they have drawn various values on this chart. Now what you see here, these are the RH lines, these are the RH lines, these inclined lines, long inclined lines, these are the RH lines. So it starts with 10%, then it goes to 20, then it goes 30, 40, 50, 60 and up to 100. Now here it is the saturation curve. This is the saturation curve, 100% RH. Okay. Now on that lines, there are again vertical lines are there, right? These are some vertical lines. Okay. Now see here, these are the values for the 12. So these are the values for the mean radiant temperature. Okay. So if you consider the total effect of dBT, air velocity, RH, so somewhere you will get the mean radiant temperature here as a 12. Okay. Then for 20% RH, this may be condition here. So these are the 12 MRT values are given here. Then here, and at the saturation condition, obviously temperature will be equal to WBT, that is a 12 degrees Celsius. So here it will be 12. Okay. So these are the constant. You can say these are the constant WBT lines. Okay. These are the constant WBT lines. Okay. Now apart from this RH, we have another two charts here. One is summer season, another is winter season. Okay. Now see here at summer season, the graph is like on horizontal. Here we have mean radiant temperature, right? On vertical, you have percentage of people who are feeling comfortable. Now, as you can see, between 18 to 26, most people will feel comfortable at this point. So this point corresponds to 22 degrees Celsius. So at 22 degrees Celsius MRT, in that case, most people will feel comfortable. So it should not be very low like 18, or it should not be very high as 26. Now in winter, again here we have on ordinate, here we have MRT, that is mean radiant temperature. Here we have percent of people who are feeling comfortable. Again in this case you can see most people, so they here it is 100. So most people will feel comfortable at this condition. This condition again refers to 20 degrees Celsius MRT. Okay. Right. So here also I have drawn it. So DBT versus WBT. Again, on this case, I have drawn the RH curves. Okay. Now there are 4 conditions I have taken. So first one is 21.5 DBT and 11.5 WBT. So that will form one of the corners. Okay. So that will form one of the corners. Okay. So see here 21.5. So here it is 20. Here it will be 21.5. It will form one of the corners. That is a point number 1. Then we have 25.5 DBT and 15 WBT. So let us say here it is, and 15 WBT. So here it is 15. So here we have 15, that is constant. So this will be point number 2, which is obtained. Third point here it is 23 DBT and 19 WBT. So 23 is here, okay, and 19 WBT is somewhere here. So when you combine, you will get point number 3. Then last one is 14, that is 17 DBT and 15 DBT. So 17 DBT, that will give you point number 4. So these are the 4 points, and if you join this, you will get a rectangle or a polygon. In this case, whatever falling inside that rectangle, that will, every point will be a comfort condition. That means it did just काही standard definition नाही की एवढंच टेम्परेचर पाहिजे एवढीच आरएच पाहिजे. If you find any condition between this rectangle or polygon, that will fall under comfort zone. So every condition in the comfort zone will be sufficient for you. So you can either go, if I take suppose this point I will take, okay. So let me change the color. Okay. Suppose I take this point, okay. The green point I'm saying. Green point is 22 DBT and 14 WBT. This is also applicable. You can choose this one also. If you are any condition where the DBT is 22 and WBT is 14, you will feel comfortable. It is the meaning of that. Suppose if you take another point, let us take if you take this point, okay, this green, another green point. Here DBT is 24 and RH, you can see it is between 40 to 50 and WBT is 60. Okay. So 24, 16, that will be also very comfortable condition. So always you can refer to comfort chart. Comfort chart will give you the comfortable conditions for human beings. Okay. So we are studying this for the human beings. So if you are going to study for other applications like pharmaceutical companies or etc., in that case the comfort chart or the required conditions will be different. Okay, so it depends again on the application, right? 2 more terms are here. We'll see. Predicted mean mode. Okay, predicted mean mode. So it is not in the syllabus, but these are very 2 important terms are there. First one, it is predicted mean vote, an index that predicts the mean value of votes of a group of occupants on a 7-point thermal sensation scale that is based on balance of heat within the human body. Okay, that means there are 7 scale. It starts with minus plus 3. So wait, let me draw. Okay, wait. Okay, it is coming. So 7-point scale means it will start with plus 3 and it will go to the minus 3. So here we have 7 scales. Plus 3 will contribute to hot condition. That means if I ask you that students how you are feeling thermally. So you have to select between hot, warm, slightly warm, neutral, slightly cool, cool, and cool. Okay. Now, if I take vote in the night, most of the people will vote between -2 to -3. And predicted mean vote, if I take the average of all, that might come up to -2.4. Right? If I take your vote at morning or at the afternoon, you may sir we are feeling neutral or we are feeling slightly warm. So your vote in the afternoon, it may come up to 0.5 in the winter. Okay. Now opposite to that, if I take your vote in the hot summer, in that case you may say, sir, some people will say I'm feeling warm. Some people say I will feel hot. If I take average of all these values, I will get a value between 2 to 3. Let us say I will get a value of 2.7. 2.7 will be the predicted mean vote of that group of people. Okay. And next term here it is predicted percentage of dissatisfied. That means how many percentage of people are dissatisfied with the thermal environment. So an index that establishes a quantitative prediction of the percentage of thermally dissatisfied occupants, that is too warm or too cold, the PPD is calculated from PMV. Okay. So in previous slide, we have seen how to calculate PMV. I will ask 10 people that how you are feeling between cold and hot. Some people will say warm, some people will say hot. So on an average, I will get PMV as 2.7. Okay. 2.7, that means if I plot that on this PPD chart, so that will be a failure of the air conditioning system. So see here how it is. Here it is percentage people dissatisfied from 0 to 100 versus PMV. Now see the graph. It is maximum at start, it goes to its minimum, and then again it goes to its maximum. So in previous example, if the PMV is 2.7, it will come. If PMV is 2.7 here, so it will go up to this point and it will reach to this point. This point corresponds to, let us say, 95 ppd. So that means 95% of people are dissatisfied with the thermal environment. Now opposite to that, if let us say PMV comes out to be 0.5 here, you can see it corresponds to this value. This value is nothing but 10. So that means 10 people out of 100 are dissatisfied. So that is very low count. Okay, 90 people are happy. 90% people are very happy. So you can say that that condition is good. Okay, another example I will take. Let us say very cold condition is there in winter at night, and your PMV predicted mean vote comes out to be minus 2.5. So if I go to this vertically, I will reach to this point. This point corresponds to again, let us say 94. So 94 people will be dissatisfied with the environment, and 6 people will be happy. But majority of the people are unhappy with the thermal comfort. So that we can say the PPD is 94%, and we need to improve the thermal comfort conditions in that room. So you may start a heater, or you may pass hot air in the room. Gradually the temperature will increase, and maybe, just maybe, the PMV will increase to -1, from -2.2 to -1. And at -1, you can see this is a PPD that is about 25%. That means 25 people out of 100 will be dissatisfied, but 75 people will be very happy. So this is the concept behind PPD and PMV. So any doubt up to this point, you can ask. Yes, any doubt? So I will follow this link and we'll check what is it. Okay, so I hope there are a lot of annotations on the screen. I will try to erase it because these are unnecessary available here. So this is a Berkeley's website which will give you some idea about the thermal conditions. We'll put some values and we'll see where these values will lie. Okay, now I will put, so there are two methods, PMV method and adaptive method. We'll go with the PMV method. Let us say now the temperature at this condition is 30 degrees Celsius. Now let us say temperature or airspeed is 0.5. Okay, so see, give attention here on this blue one. So this blue band will represent the comfort condition or the right now conditions. Okay, this is a reference point. The yellow, the dark point here, it is a reference point. Now relative humidity, let us say at this point is not 50%. It is let us say how much. We'll take lower. Let us say 35. Okay. And now metabolic rate, we are as typing or reading, it will be 1. Clothing level, let us say it is less, or it may be 0.5 to 1, right? It may be 0.7, okay? Or let us take very large, let us say 0.8, right? Now, as you can see here, this is the chart, okay? In this case, our point lies here, right? 30 degrees Celsius and 35% humidity and air. Okay, that is it. 30 degrees Celsius dBT and 35% RA. So this is here. But as you can see here, the comfort band lies here. So we are not in the comfort band. Okay. Now what to do? That we should be or we will be in comfort band. In that case, I have to increase the humidity. Let us say let me increase the humidity to 60%. Okay, still we are not in the comfort. I'll decrease to 50%. Okay, here. Now I will increase the airspeed. Let us say it will go to the 1. Now you can see we are very nearer to that thermal band or thermal comfort band. What should I do here again? I will decrease some clothing. Okay, I will wear very light clothes. In that case, it may go to 0.6. Yes, now I am in the comfort band. Now I am in the comfort band. Okay, now this point is coming under comfort band. Now I feel very comfortable when my clothing level decreases. So I'll share this link with you. You can play with it. Now see here, at this condition, 30 degrees Celsius dBT, airspeed is 1. I have started fan. Now that is giving me airspeed as 1 meter per second. RH I have maintained 50%. Metabolic rate is 1 because I am just talking or writing or typing, etc. Clothing level I have decreased to 0.6. That means very light clothes I have wear. So in that case, you can see here percentage of people elevated speed are 8%. That means 8% people will be dissatisfied, but 92 people will be happy with this environment. Now next you can see PMV comes out to be 0.39. So it is between 0 and 1. Again, it is very good value. Okay. Next, okay, this is good. Okay. So you can play with this also. Suppose now outside the condition is 35, or let us say at night condition the temperature may drop to 15 degrees Celsius. Okay. Now we are at very large or we are very far from the comfort conditions. Now what I have to do here, I will decrease the airspeed. Let us say 0.1. Now I am somewhat nearer to this. I will increase, or should I decrease? I will decrease the relative humidity. Okay, no, it is not good option. So I will just maintain it as it is. Now what should I do? I will increase the clothing level. I will go up to, let us say, one cloth. So gradually I am coming towards the comfort condition, but still the temperature is very low. Whatever you do, in that case, it will be not sufficient. I have to increase the temperature to, let us say, 20 degrees Celsius. So I will be very nearer to the comfort conditions. I will be very nearer to comfort conditions. Oh, now it is giving a warning here. Does not comply with ASHRAE standard 55. So this condition should not be at any conditions applied to the living environment. Okay. I hope you are understanding this. So now for this condition, you can check the PMV is minus 0.88 between 0 to -1. Percentage of people is dissatisfied is 21. That means 21 people out of 100 will be not satisfied. But remaining 79 people will be happy. Sensation is slightly cool. Okay. Set is 22.5. This is the effective temperature. Here it is 22.5. Okay. Any doubt? So with this, our chapter number 5 is completed. For ISC 2, I will ask from chapter number 4 and chapter number 5 and some part from the chapter number 3 also. Okay. So put your comments, or sorry, roll number in the chat box, and then we can stop. Yes, put your roll number in the chat box, and then we can stop. So for ISC 2, I will ask from chapter number 4, chapter number 5, some part of chapter number 3 also. Okay. One more chapter is remaining. We will cover shortly after ISC. Okay. All right. So with this, we'll stop today. Thank you.